Hello everybody, welcome to this presentation of modern UX patterns based on serverless architecture. So together with my colleague Mohamed Bouchenafa, we're going to introduce ourselves. So first, who are we? I'm Antoine Palaviu, I'm a senior consultant for almost 10 years now at SmartWave. I'm specialized in application integration based on tools such as Oracle Service Bus, SOA Suite, or using WSO2 components. And for a few years now, I've been involved into DevOps projects. So with technology around infrastructure provisioning, with tools such as Puppet, Ansible, and also involved into the cloud technology, and knowing that I'm a solution architect now.
Hello, and I'm Mohamed Bouchenafa. I'm a senior consultant at SmartWave since 2014. I'm specialized also on DevOps. I work with some clients to help them approach this kind of work, help them to go to continuous delivery also. And in fact, I'm also a Java developer and Java architect. And I work a lot since 2015 on AWS, and I'm certified on the development side.
So first, what are we doing as a consultant at SmartWave? Let's take a use case. So as consultant, we are working sometimes onto prototypes, labs, or demo for our customers. So this kind of work involves handling quite different technologies and tools. And most of the times around these prototypes and labs, it's quite short notice. For example, our salesman calls us on Monday evening, telling us that we need to do a demonstration in 1 or 2 days to a specific customer, a new customer or current customer, about a project, about a demo, about a prototype that we did maybe a few weeks or a few months back. So let's take this use case and show you how we can handle that at SmartWave. So first, about our context. SmartWave is a Swiss-based company based in Versoix, next to Geneva. We are established since 2000. We are IT consulting company, and we are now around 50 employees. So about our IT expectations, it's aligned with the size of the company. We have no dedicated employee around our IT, so it's work that is spread around many different people at SmartWave. But still, we need our IT to be aligned with the market and to support our company growth and adapt to the business requirements. So the key figure here is to remember is 0.6 FTE for operations, meaning that we don't even have one person working full-time on our IT. So it's divided between many consultants, and it represents 60% of full-time equivalent.
These key expectations led us before 2011 and to go since 2011 to adopt more cloud solutions. Before 2011, we were only using some cloud solutions like Atlassian and Google to solve technical pain points. But from the moment we began to use AWS in 2011, we also adopted a cloud-first strategy. And now most of our systems are in the cloud. This cloud-first strategy helped us build our legitimacy and led us in 2016 to become an AWS consulting partner. Now, let us share with you our experience. At SmartWave, we early adopted the Docker containers to smooth our deliveries and modernize our monolithic systems. So we early began to wonder what should be the infrastructure to run the containers and manage the images, and how our colleagues can adopt this new way to work easily. And as we were and having a cloud-first strategy, we considered to run containers and manage images using AWS. But how to do it? Fortunately, AWS proposed ECS, the Amazon EC2 Container Service. It's a highly scalable, fast container management service that makes it easy to run, stop, and manage Docker containers on a cluster of Amazon EC2 instances. The only thing you pay for is the Amazon resources used to host the containers like EC2 or EBS. Now, we answered to the infrastructure question, but we still have some challenges. Like, how can we provide a self-service system to give to all SmartWave users the ability to manage and use freely a selected set of containers, and how we can do it with the smoothest user experience? How can we limit our expenses in terms of billable Amazon services like EC2 instances? And how can we give access to ECS to people that don't have the necessary skills and the right permissions? Let's see with Antoine how we answer to these challenges.
Okay, thank you, Mohamed. So let's go back to our use case. So if we need to do a demonstration of our prototype to a specific customer, for example, on a HTML page that Mohamed has developed a few months back, and I can't call Mohamed on the phone or join him anyway, so I need a really easy way to launch this HTML page, HTML project, and show it to the customer. So first, what we want to do to implement that is to give the power back to the user. So for that, we thought about using the serverless architecture, because it requires no management from SmartWave side. So based on the 0.6 FTE, this is really a good thing for us. And what we wanted also is to have a very intuitive way to use this interaction, to use this system. So for that, we thought about Slack, which is a very famous chat system that allows users to interact. So for the serverless architecture, based on our knowledge of Amazon, we thought about using Lambda, of course, which permits to develop functions in Python or Node.js, and just deploy this code and make it runnable. And for Slack, as we don't want to have a user to reply to our specific expectation, we thought about handling this interaction with a bot. So let's call it SmartBot. So let's start with the demo of this SmartBot. So let's connect ourselves to Slack. So I'm using the Slack account of Mohamed. So we can see on the left up there that the SmartBot is just as a human user. It's a technical user, but still is connecting and is live, so we can interact with this bot. So just to show you, I can type hello to him, so he should be able to reply and be as polite as possible. Okay, he has replied finally. greetings. So with this bot, I can ask some help, and I can list the available smart apps that are handled by this bot. So the bot here is showing us the different Dockerized application that we own as SmartWave, and that is able to handle, meaning that you can start and stop them and describe them. So for our use case about the HTML page that Mohamed did a few months back, I want to start this Docker container. So I will ask the bot to do that with just a simple command: start smart apps awesome day. So the bot has understood what I want to do, which app I want to start, and is asking me for how many days I want to run this container. So I just say 1 day. Okay, so he has already replied that he has started this container with a specific ID that you see here. And what I want to do now is to describe these smart apps with this specific ID. And so he found this this container with this specific ID, this task on running on a ECS cluster. And I can already connect to this application using this URL that the bot has provided. So we can see this awesome page with the awesome man showing the page that Mohamed did, and I can now do my presentation to the customer. So let's go back to our slide and explain you what just has happened. So first we connected ourselves to Slack. Slack is of course independent from Amazon. This is a chat system that is not owned by Amazon. The bot himself is running on a Docker container on a ECS cluster on Amazon. So once this container is up, he's connecting himself to Slack, and this is just the way that when I show you that the SmartBot is up and running and live, and that is able to interact with other users. The other users here are SmartWave users that can interact with this bot. So when I ask the bot to list the available smart apps or to start the awesome day app, this was sent by the SmartWave user to Slack, then to the bot, that finally triggered a call to our API gateway that is exposing Lambda functions. So finally, after the SmartWave user has triggered an instruction, it's finally arriving to a Lambda function that is triggering a specific call to the ECS cluster where our Dockerized app are handled and can be stopped and start. And finally, also the Lambda function has enhanced the response with some metadata that are coming from a DynamoDB table. And then the reply just went back through Lambda API gateway, the SmartBot, through Slack, so the user can see the result and interact positively with the bot. So this is what has happened when I interacted with the SmartBot. Just to show you a little bit of code, we can see here really key example of the code that handle what the users are trying to say to the bot. So with some specific keywords, and some regular expression, the bot is able to route finally the the instruction available smart apps or smart apps available to a specific API gateway call. So it means that any instruction that you want to do with the bot, you will need to add some code that is just looking like that. And for each keywords, you will need to enter yourself the typo error. For example, when you type smart apps with 3P or with no S, in our case, we didn't handle that. So it means that the bot won't understand himself what we are trying to say. So it's true that it can be a headache to manage. And of course, if you have 1000 kind of invocation you want to do with the bot, you will have lots of code to handle and manage and maintain. And this can lead to some cumbersome task. So about this SmartBot V1, the SmartBot is a Dockerized application that is made of Node.js that is running in a container, a Docker container, and itself is running on the ECS service of Amazon that is managing the containers. So the thing about this bot is that it's not serverless because it still needs an EC2 instance running on the ECS cluster that needs to be started and that will handle the container. So they are placed for some improvements.
Yes, thank you. Okay, the proposed solution answered to our need, but after using it, like Antoine said, we've seen some limitations, like the need to enter the exact keywords to question the bot, and always having an EC2 up to host the bot container. When AWS launched Lex, we've seen a possibility of improvements. Amazon Lex is a fully managed serverless service that allows developers to build conversational interfaces for voice and text into applications. With Lex, we can easily build natural language conversational bots because Lex provides automatic speech recognition, which converts speech to text, and natural language understanding to recognize the intent of text. So, no more exact keywords. The bot should be now more comprehensive. Then we replaced the Node.js bot by a Lex bot. Now we will show you how the Amazon Lex work with the integration on Slack. Let's go to Slack. On this demo, we will show what we can see is that we are using another user which is connected to the Lex bot on AWS, and what we can see is that we can ask him to list the applications that are available, but by telling him giving him a human sentences and not a command with a keyword. So the bot responded with a list of available applications. What we can try is to run an application. For example, no, not this, but the AWS someday demo or someday demo. The bot responded and launched the application that we wanted into a Docker container on ECS. and he gives us the URL that we can test, and we can see that he effectively launched the application. If we can go to Lex and show you that, in fact, a Lex bot is a bot that you can use to describe the intent that the user can give to the bot. For example, here we can see that to describe an application, we can give him some sentences, and to list running application, we give him some other instances, some other sentences. For example, we can show you that this bot can respond to other sentences that are not already defined on his set of utterances. For example, I can say, give me the instance that are up, for example. And he answered with some sentences. In our case, the Lex simulation console don't show the list, because this list is formatted for Slack in our case. But we can try another example with the available apps and give him an utterance that doesn't exist in his set. For example, I can try not list me, but something like what are the available apps, for example. And he answered with the list of available apps on text, of course, because the Slack formatting is only for Slack and can't be parsed in the simulator and the Lex simulator. What we can try to do is to use the voice capability of the Lex bot. And for example, we will try to have the same utterances with Lex. What are the available apps?
Here are the available apps: Awesome Day Demo, Bonita Onboarding Task, Console Sample App, SmartBot Dev, SW_website, Ubuntu Task. So
the bot responded with the voice. He understood what I've said, and he translated my voice command to a text command, and used this text command to know what the intent that the intent that I had, and translate it into a call to the lambda function that it should be called. In fact, let's try something else. Continue presentation.
Sorry, can you please repeat that?
Of course. Continue presentation.
Hello, I am the Lex Serverless SmartBot. I will continue the presentation from here, because those guys aren't doing very well. Please listen to me. I will not repeat, and I will not stop. That's our previous non-fully serverless architecture. It was good, but as I was not in it, it was not so good. And this is the new architecture. I took the place of the lazy Node.js Dockerized bot. Okay, now I'll stop. Come on. You really thought I was going to finish the presentation?
Okay, I will take it then. This schema is showing that, in fact, the only thing that we changed is that we removed the SmartBot and removed the API gateway and replaced those two components by the Lex services, which directly can call the Lambda function and assume the security and the different things that the API gateway do for us when we call the Lambda function. And now we have a more human-centric human experience and don't have to manage an EC2 instances to host the bot, because everything is now serverless. Okay, now let's finish by some key takeaways. With this experience, we were able to make users more independent to access an ECS and Docker resources, manage dynamically our containers and stopping them automatically like Antoine showed earlier. By combining the right AWS services like Lambda and Lex, we limited our costs and effort and kept the platform open to changes like we've seen with the Lex improvement. We were also able to provide a simple and human-centric interface by using a common used communication channel and an intelligent bot. Finally, what we've done is only an example. This approach can be extended to manage resources like EC2 or RDS, or to integrate private or public APIs with Lex bots to provide a better UX. That's all, folks. For more exchange about AWS, you can contact us through LinkedIn and ask us any question you want. Thank you.
Thank you. Bye-bye.
Bye.